This is a video presentation of Chapter 2, Section 6 in the 7th grade textbook entitled Prime Factorization. And our objective here today is to find the prime factorizations of composite numbers. So, we're kind of in a new unit of study here, so let's give it a little bit of an introduction here beyond the objective. We're starting to talk about just the process of working with numbers, not so much operations, although we do encounter that, but it's kind of the fundamentals of numbers. And the two things they're talking about here are really related to divisibility, the concept of prime and composite. A prime number is a number that's only divisible by 1 and itself. A number like 3, for instance. What positive integers can I divide out of 3? Well, I can do 3 divided by 1 and 3 divided by 3. Because the only numbers I can take out of it are 1 in itself, that's a prime number. A composite number is going to have something else on the list other than 1 in itself. So, for instance, the number 4. Well, 4, I can do 4 divided by 1, and I can do 4 divided by 4, absolutely. But I can also do 4 divided by 2, and the result would be a positive integer. So that makes that a composite number. Now, that does leave a few questions there to talk about. Most specifically the number 1. 1 is considered to be neither prime nor composite. 1 is, even in the best case here scenario, considered a special number. Because, of course, when we're saying itself and 1, well, that's the same thing if we were talking about the number 1. 2 is also kind of an odd duck because it's an even number, and it's the only even number that happens to be prime, because every other even number is going to be divisible by 2. So a lot of times they say 2 is the oddest prime of all. Math joke intended there. All right? 2 you have to know is a prime number, but all the rest of the even numbers are composites. And you can go ahead and test, once you find a number that divides out other than 1 in itself, it's automatically composite. If you don't find anything, it's prime. So let's give some proper definitions here. Prime number is a whole number greater than 1 that has exactly 2 factors, itself and 1. And a composite number is a whole number that has more than 2 factors. Now, the other thing we talk about here is prime factorization. Prime factorization is through a process called factor trees usually, although there are other methods you'll see in this instruction here today. But prime factorization is writing a number as the product of its primes. It's theorized that any number can be written as the product of its primes. Now again, I say it's theorized because of course numbers are infinite, and as we keep going through numbers we have to test everything. But that's the theory, that every number can be written as the product of its primes. And that's exactly what prime factorization is. A number written as the product of its prime factors. Okay, so let's continue on then and start taking a look at some examples here. We'll go ahead and start off with example number 1. We're supposed to simply tell whether the number is prime or composite. So you want to check for divisibility here. If you find something else that goes into the number other than 1 in itself, it's going to be composite. If it's only 1 in itself, then it's got to be prime. So the first one there is 11. Well, we know 1 and 11 go into 11. Is there anything else? Well, we can run through and check. 11 divided by 2 does not yield a positive integer. 11 divided by 3, 11 divided by 4, 11 divided by 5, 11 divided by 6, 11 divided by 7, 11 divided by 8, 11 divided by 9, 11 divided by 10. Those all have the same problem. They do not yield a positive integer. Notice I did not say that they couldn't be divided. They absolutely can be divided. The result is not a number, though, that shows up on the number line. It's not a positive integer. So that said, that is a prime number. Now, in the other case, there was 16. All right, we know 1 and 16 have to go into 16, but is there something else? Well, if we go to the first number after 1, we go to 2. 16 divided by 2 works. And that's going to make that be composite. Now, Yes, there are other numbers there. As you can see from the notes, we can do 16 divided by 4 and 16 divided by 8. True. However, you don't need to go that far if they're just asking you prime or composite. Once you find one other number that's a possibility, it's automatically composite. It doesn't matter if there's 10 other numbers I can divide out or just one other number other than one in itself. That automatically makes it composite. All right, now number 2, they're asking us to write the prime factorization of the number, and the number happens to be 24 here. Prime factorization can be done a few ways, as I mentioned in the definitions, but the primary way we do that is with a branching diagram called a factor tree. What you're going to do is create a tree that runs north-south or vertically, whatever you want me to say, and in that tree there, each lower level of the branches there, as we go down is what I'm trying to say, all right, is the product of the number that is above it. So, for instance, if we had 10, all right, beneath it we could write 5 and 2, because 5 times 2 makes 10. And you keep going down the branching diagram until you have all prime numbers. And once you've primed out all the branches, you then have prime factorization. You take all those prime numbers that you have written and put them together with multiplication signs, and that's what makes it prime factorization. Again, there are other ways to do this, which we'll see in just a minute. So, 24 here. All right, we'll take this question as an example, and then we'll show it to you another way here. 24, they decided to go with 8 and 3 here, which is quite fine. All right, so, going down the right branch there with 3, 3 is a prime number. So I don't have to do anything else with 3. As you can see, all they're doing there with 3 is they're carrying 3 down the branching diagram to indicate that they've finished with it. That's what you see going down the right side of the tree here. Now with 8 is not a prime number because there's something else that goes into it other than 1 in itself. So they decided to go down to 4 and 2 here. Now 2 is a prime number, so that side of the tree diagram is done. But 4 is not. So 4 will have to be continued down the path here. 4 gets broken down as 2 and 2. And now we have all prime numbers at the bottom of the tree, so I stop. My prime factorization here is the product of these numbers written together, 2 times 2 times 2 times 3. All right, now, there are other ways to do this problem. You can break 24 down any way you want. You can break 24 down as 4 and 6. You can break 24 down as 12 and 2. Those are all working possibilities here. Let's quickly go through those. Here's 24 as 4 and 6. 4 gets broken down as 2 and 2. 6 gets broken down as 2 and 3. And notice that the answer that's written here is the exact same as the answer that's written right here. Right, we can break 24 down as 8 and 3, which is the other option. 3 is a prime number, but 8 is not. 8 will get broken down as 4 and 2. 4 will get broken down as 2 and 2. And again, notice that the answers I had here at the bottom are the exact same as my bottom here. A 2, a 2, a 2, and a 3. All right, here's 150. We won't go through all the possibilities here, but there are some. 150 gets broken down as 10 and 15, as you can see here, because 10 times 15 is 150. Remember, we can stop with a branch once we get prime numbers. Well, neither of these are prime numbers, so we have to continue on down both paths here. 10 gets broken down as 5 and 2. All right, 5 and 2 are both prime numbers. 15 gets broken down as 5 and 3 because 5 and 3 are both prime numbers. since all these numbers at the bottom of my tree are prime, I can stop now. I'm going to write those together with multiplication signs, and that is my prime factorization.